Yeah, okay. Now it's recorded. Thank you. Thank you for reminding me. So this is what the second one, which is ground. Okay, going to the second part. Okay, this is the ground one, and this is the VCC, and I then have to connect signal one. So signal, it's optional. You give any kind of color, but ground always try to give it a dark color because you won't confuse in connecting your VCC and ground to your Arduino. So we have our IR sensor now. Okay, it got three cables. So three cables connected to it's three of them, and we all remember what exactly the white one stands for. So now on this Arduino, where should I connect the VCC and ground? So obviously there are few power pins which are dedicated to connect your external peripherals. I need to give the VCC coming from it to the 5 volts or 3.3 volts, nothing, there is no difference. Connected it to VCC and ground next to it, there is a ground pin. So I'm going to ground, and this signal wire is it can sit in any of the digital pins, right? Because this is a digital sensor, I can connect it to any of the digital pins. Hence I'm trying to connect it to this maybe 8. Okay, 8 pin. Clear everyone? Connections, VCC, ground, signal. So you all know the working of your IR sensor, and if I'm not wrong, in a previous class for some people's ideology, I just changed the what you call its particular sensitivity so that it will directly operate in a reverse fashion. Like if there is no object, it has to go one, and if there is an object, it has to go high. What if we have to connect more than one external device, VCC and ground, on single port each, right? Yeah, at that moment, I request you people to go to the breadboard. Okay, you all guys know how to use breadboard? There are some series and parallel of connections, and you can use there. That's a good idea. If you have more than one or two components, better you can use your breadboard. So here is our IR sensors program. Okay, here is our IR sensors program, and you can still see this particular video, whatever I'm showing you in the participants page, whichever is highlighted, because I'm spotlighting the video, and I'm also once again in video. Yeah, see, you can see the video there, and you can see this program here. I haven't connected any what do you call this LED, so I want to just make it commented. So there is one more new trick that you all like to remember, that if at all you want to what do you call, one second, you want to comment something, these two slashes, okay, two slashes, whatever you use, will make the line, entire line, commented. So now your questions will start. Serial.begin. Why I'm using serial.begin? Because I want to print the status of the IR sensor in my serial monitor. This was your question in the previous class. So what I'm trying to do is, first I use serial.begin to 9600, which is the proper baud rate in which your Arduino will work. Let us try without using 9600 in couple of minutes. But until then, let me first try to execute this and check. Got it? Yeah, hope you all will be satisfied. If I change the baud rate and show you the story also. Yeah. So now your Arduino is connected, your IR sensor is also powered up, you made it correctly. Now, what you all need to check is, first go to tools, okay? Go to tools, check port, always check port, and whatever is the port shown to your particular audio, you need to select it and go to our board, select your Arduino Uno, because you're not using Nano, Diga, or Leonardo, Micro, anything. Lilypad, you're not using anything, you're just using Arduino Uno. So you need to select it. And I think I need not to explain this program more and more clearly, because everyone is understanding, because we already made a clear picture about this. Let me try to upload. Whenever, I think I told you, whenever you try to upload the program, it always gives you something like what do you call, compiling and then uploading. Okay, yeah, I think I need to comment everything here, because if is commented but not else. So you see the status there, the side one done uploading. Now let us see to our serial monitor. One second. To project the serial monitor, I need to stop the share and share my entire screen so that, yeah, you'll be able to see it. Here, let us see in my serial monitor. So what is this answer? It's going on 0. So there is no object in front of it. Let us try to have an object. 1 0. It obviously working in a reverse fashion. As I told you, the sensitivity of it is completely changed. When there is an object, it shows you 0. When there is no object, it shows you 1. Got it? Clear, everyone? Understanding? Yeah. Now your questions will start. I'm just switching off this. Yeah. What if my baud rate is not 9600? That was your question, right? Let's change this to, so to know what are the possible baud rates, if you want to know it instantly, open serial monitor again. You see here it is 9600 checked, right? Let us take one of the possible baud rates, maybe around 57600. Let us try to set that 57600. This was, and whenever you change program, so I'm not doing anything now. So for your understanding, see, I'm not doing anything here uh, unless and until I upload the program again and change the previous state memory. The previous program, whatever you uploaded, will be going on running. The very best example to that I'm going to show you with the help of your LED. Okay, so now let us see. It's done uploading, and now let us see the serial monitor, what it is showing now. You see the answer there. What exactly you are getting? You are getting some random values, right? They don't have what you call auto scroll is now off. You see there. What are the answers that you are getting there? CB, some random values. We don't know, right? So let's clear the output and let's get back to this. Now let me again change this baud rate to maybe I should select one from the possible baud rates. Let me go a little higher. 115200. Okay, 115200. So let me upload the program again. It's done uploading. Yeah, done uploading. Now see the baud rate again. So what are you getting again? Again some random values. No, it's not given 9600 here. So if I select 9600 here, then your answers would be different. Okay, whatever you select here, it's not that you are selecting that particular baud rate. Your program in serial.begin, whatever you gave here, it's gone uploading it. Okay, it went uploading it. Unless and until you have some kind of communication, like I give a raw data from serial monitor like 1 and 2. See, I gave 1 here, then if I press send over here, okay, it means I'm communicating in a reverse fashion. And there is something called serial.read. Okay, serial.read and serial.write, which accept from serial monitor. Okay, we use it for GPS, we use it for Bluetooth and some other kind of communications. So at that moment, it is what exactly is happening. Now let me close this, and now let us go to some our previous baud rate, 9600. Okay, now let us see what exactly this print ln is also doing. I'm writing print ln and again uploading it for your understanding. So I think previously it was just serial.print, and now we are giving it serial.print ln. So now we are getting each and every time it is printing in a new line, right? It is printing in a new line. Clear? So I'm projecting it to air and projecting it to my phone, whichever is on the tripod here. It has to give 0. See, to the camera, whatever you are seeing, I'm projecting it to it because there is an object in front of it is giving 0. And if I just tilt it to air, it is giving me 1. Got it? Clear, everyone? IR sensor working. So, will you all do work with IR sensor on our simulator at least? How many of you are ready to do so? Shall we all see the program to understand about your ultrasonic sensor? Yeah, this is your ultrasonic sensor. Let me show you that. So this is your ultrasonic sensor, okay, whichever is used to what is called a distance measuring sensor, you can call. Got it? So in this distance measuring sensor, what exactly is there? So you have two kind of resonators we can call. Okay, the first one is echo and the second one is trigger or vice versa. Because if I show you in this fashion, you don't understand which is echo and which is trigger, right? One stands for echo and one stands for trigger. It means the echo one is always try to accept the waves whichever come to it. The trigger is always to send the waves out. So whenever I give one digital high to trigger, it means it is giving a sound wave, and if it hits the object like this, and it has to again come back to, it means there should be a reflection, and that reflection is accepted by your echo. So it means there are two functions that they are independently driven. So what do you guys understand? There should be one trigger pin obviously and one echo pin. It is not only one digital or one data out that is having in your IR sensor. Okay, it's not like your IR sensor that you need to only have one signal wire. Okay, you compare this both, so you will understand a little more better. In IR sensor, what happens? You need not to do any kind of trigger and echo. You once connect the signal wire, and once you give the power up, obviously there is something called the power pass to your IR photodiode, and sorry, IR LED, and through that the IR waves are coming back out. But when it comes to this ultrasonic, you need to give a trigger, and then it sends the waves out, and then you can accept it from here. Let us try to implement this, and of course as I need one more wire to be used instead of a servo. So instead of your IR sensor, I need to plug one more wire. Yeah, let us use 8 and 9 because everything is digital here also. So let us try to use 8 and 9 now. Yeah, so this 9 I'm giving it to echo. Okay, and 8 trigger, I'm giving it to trigger 8 1. Okay, and obviously VCC and ground, you guys know VCC, it means positive has to be given to VCC, and this negative ground has to be given to GND. Yeah. This is how your connections goes on for an ultrasonic sensor, and this is how your wiring diagram looks like, because echo and trigger, VCC positive and ground. Okay, let's see how this works. And yeah, let me open your IR's ultrasonic sensors working. So there was a small what do you call adjustment that is made, because there is, I cannot what do you call give you all the direct motor of working of this DC motors with the help of your motor driver circuit, because there is some pin and some connector missing right now. Okay, but obviously I'll show you in the second hardware session probably. All right, yeah, let me share you your ultrasonic sensor screen. See here, so you can still see the video in the pinned mode, that is pinned in the bottom if you are using mobile or desktop, right corner, in the top right corner. So what I made here, I used two different pins. Echo pin is given to which number? Can anyone? I need not to check because you guys can tell me you're hearing the class, right? No, not here, but in our connection. I think it's 9 and this is to 8, right? So this is what I made. I gave connections to both of my echo and trigger pins. So I defined it because I need not to change it anywhere in the program. What's it? That's why this particular defined type of declaration is done instead of int. Okay, I defined those two pins because I'm going to use these names, echo pin and trigger pin, all around in the program. Okay, and let us see. When it comes to first thing, here you have long duration int distance. Why long duration? Because this is not 2 or 3 or 4. They cannot be a step function, but they can be any kind of floating points. Okay, because if you guys remember the formula, this is the wave whichever is hitting this, and this is the reflected wave. So what is the formula to find out the distance? S is equals to velocity of sound into distance traveled time. But we are almost taking it by half. Why? Because the wave is traveling 2 times, right? 2 times, the wave is traveling 2 times, hence we are taking it into half. So this time, which is called the duration of the wave to travel, okay, from each trigger pin to another trigger pin, we gave it as floating, or you can also call long, the data types and the differences. I need not to tell you all, but a lot of people know. So yeah, let me clear this. Let us get back to our program now. So what is there here? Pin mode, trigger pin output, but echo pin input. I think I don't want to speak about input and output again for multiple times, but because most of you guys know. Now serial dot begin 9600, serial dot print, this is test. This is all not mandatory. You can just comment them. Yeah, you can just comment them because just to they are just the signs of your work. Now let's come into your program. What we are doing here, we are giving first initialization, we call it. Okay, initialization. What exactly means initialization? You are making it to sit to the known value. Okay, your known value, you are making it. What is known value of any kind of digital sensor? It's 0, right? And instead of we cannot give 0 here, we give it some condition called as low. That's it. Okay, so you do the same thing. You do the same, like you give what you call low pin to the trigger and make it a delay or wait for 2 seconds. And even this is not mandatory. You can comment this if you don't want to wait. Once you give it a low and immediately you want to start, you can do it. And then what I made, I gave trigger high. I gave a microsecond of, this is your wish. I can increase this or I can decrease this. It is absolutely your wish. Okay. And because I want to wait for 5 milliseconds, I just give it. Okay. So I can give it or I cannot. That's up to you. And then trigger pin, I'm making it low. It means the pulse goes in this fashion. I make it high for 5 milliseconds and then I can make it low. Okay, when I make it low, in this 5 seconds, the wave is now sent out from the trigger. And if you have anything whichever is hitting your sound waves, it gets reflected. So it is reflected means it is captured by your echo, and that echo resonator is capturing those waves. When they are captured, the output from the echo pin will be either high or low, right? If you enable the echo pin to go high, it means you're accepting the waves, and it means this is the difference between which I send the waves and it is accepting, and this is called as duration. Okay, duration. So this pulse in is a new function to most of you. What exactly the pulse in will do? Any idea to anyone of you? Anyone can tell. If you have any idea what exactly is pulse in? No one? See, I explain you what exactly is happening there. So I think at least you can guess, any wild guess. Time to receive. Okay. Pulsing is a function which measures, any idea? Yeah, yeah, pulse which is sent. Okay. Anyone? Yeah, because someone is trying to explain, speak. That's why I'm just waiting for you all. It actually measures the time period in which the signal is going to high. Is it okay? Okay. Pulse which is sent to recognize. Yeah, waiting for your answers. Okay, I got two answers, three, but I think not exactly. You can think once more. How about others? Actually, the time period, okay, because duration itself, whenever I told you, you might have guessed it. I thought you'll guess it, but not a problem. Yeah, checking the pulse is high or low. No, when to check the pulse which is high or low, you can use directly a digital read, right? Okay, you can use digital read at that moment, but that doesn't make sense. Yeah, person who's this name, let me call out the name. Mm, Jyoti Swaroop. I think you're almost correct. You're almost right. Yeah, someone else? Okay. So see, this exactly is something like this. Not a problem. So this one, this pulse in echo, what exactly I mean with pulse in, okay, let us first explain in the whiteboard so that you all guys can hear me more easily. Yeah, in this pulse in, what exactly it does is it reads the state of the digital pin that you are connecting to it. It reads the state. Okay, if that state is somewhere like high, for example, or if it is low, for example. Okay, let us assume this is high or low. No matter whatever might be the state of that particular digital pin, it reads the state. Okay, and then what does it do is it waits or it measures the time. Okay, it measures the time that it is taking for this particular state to change from one to another. Got it? So obviously the time duration is measured. That's a true answer. I don't tell like wrong. But what exactly I mean is this is a timing function. Okay, this is a timing function. Okay, what does this do is it will straight away whenever you ask like give the second argument either as low or high, what happens is it waits for that state to go to that particular state whatever you give the echo pin has to go to high. Okay, for example. Okay, 1 second, let me wait. Pulse n, and you gave this first argument as a pin and second argument as a high or low. So whenever you give this type of pulse to read, okay, type of pulse to read, okay, then what happens is this particular signal, whenever your digital value will get this particular signal, it will then read the duration it is taking from the previous unknown state to this value whatever it is decided. So I give low. Maybe the previous state was high and it is this pulse in function is waiting to realize the time duration at which this high is going to low. So it is something like a timer. You start it from zero and it is going to low from high to low after 5 seconds. And this is stored in a variable that is required. Got it? Clear everyone? Second argument is what state to wait for. Absolutely. Yes. what state it has to go, what state you want to measure when the value goes to. So if you give the previous state itself and you know that it is never going to change, the value will definitely will not be anything. It could be zero completely. Yeah. Now the same thing made over in your program. Let me share the entire screen so that I can also share you the serial monitor. Yeah. So this is what exactly the duration is, which is nothing but your time, which is nothing but your time. So as there is one time, what do you call, function called pulse in, the everything is made very easy. But if not, it could be very difficult for people to understand after how much time they have to measure the time. And they give approximately 5 seconds, microseconds, and that will definitely lead to an error if the object is too near to them. So now once the time is calculated, what is required? What is required? This one. This is a simple formula. This is a simple formula. What I made is 340 meters per second, made it to some kind of meters, centimeters calculation, okay, to calculate the distance depending. If the resolution and the range of your sensor is in meters, you can directly give 340 multiplication factor here. That's not a point, okay. And I already told why are we dividing by 2, so I think no one will confuse if I'm dividing the value by 2. Yeah, and the next one is printing distance, printing in centimeters. That's it. Very simple, straight away. Clear? Shall we execute this program and see what exactly is the output? You have some concerns like you want to change something over here. Also, please let me know. I'll do it. But I'll also explain a small mistake that everyone will generally make on the first attempt. I'll also explain it. But once before that, let me try to execute this one. Yeah, I'm stopping the yeah, I'm not stopping share. I'm just pinning the video to your. So I think the connections are already done. Let me connect it. Yeah. So see, that's why if anyone observed or not, similar to that of a crystal oscillator, you have a small oscillator over here. Anyone able to see this? Okay, this one. Sorry. Yeah, this one. There is small resonator because it has to give some particular frequency of resonation so that these two will I mean like the trigger will give the waves out. It's all you need to observe. That's what you need to observe when you speak about those components in electronics. And if you're not observing it, you are observing your output. Even that's true. I'm happy at least. Yeah, I'm just uploading the program. Okay, and I think I need to check for port. Yeah, everything is fine. Uploading, done uploading. Yeah, let us see the output in the serial monitor. See, okay, let me not stop auto scroll. You see that distance 10 centimeters, right? And what else we are printing? What do you think this 648 is? What do you think this 648 is? If you have observed program, you are printing something. What is that? It's duration. Okay, it's duration. So let me stop or close the serial monitor and show you. See what you are printing here. This one. I'm just highlighting. See that one. Serial.print ln. Okay, this is given in microseconds. Why? Because your Arduino will always understand time in microseconds. So it is printed in microseconds. And if you don't want to do that in microseconds, very simple, multiply this particular duration, okay, into 0.001, for example, into 10 to the power of minus 3. And let us see. Oh, sorry. I think I need to multiply it by 1000. Sorry. I'm not wrong. The answer would be more. Yeah, great. So this is what exactly you get when you try to understand the seconds it is taking to measure the distance. And also for your understanding, let me put a small object in front of it which is near to it. So you see that distance is less than 2 centimeters, 3 centimeters, less than 5 centimeters. Clear? I'm moving away, the distance is also increasing. And I'm moving very near to it, okay, very near to it. And even I try to close it completely, okay, like this, the distance is less than. Why you cannot have a zero distance here? Any idea? See, the distance is 3 centimeters, 2 centimeters, and even if I leave it to 8, okay, it goes to even 64 centimeters. Why? Because your particular sound will travel not in like your IR waves or anything. It's not like to travel in a straight line. That's the point. Understood, everyone? When I was discussing about sensors, I stressed a point that you have a very problematic situation if you are using sound as your sensor technology and light as your sensor technology. Hope you all guys remember it, right? So one more point you can add here, even though I'm trying to close entirely with my hand, it is still able to find out the distance of my hand from the resonator. It means the trigger pin. So you cannot completely close sound because it travels in arbitrary directions. It travels around throughout the surface. Clear? Got my point, everyone? So let us also see, okay, how your particular L293D, and also we'll also see the program for your servo motor. And I think that could be your last one because I don't have stepper and DC motors straight away to show you. Yeah, see, this is how your particular L293D will look like. And this is what it is showing in your simulator. It's L293IC. Okay, this is what the integrated circuit that has been shown to you all. Yeah. If you have any questions, you can ask me regarding the connections or anything. Okay, anyone, any doubts? No doubts? Okay. Yeah, let's see. So when it comes to this connection diagrams, this one, okay, this positive and negative generally goes to one motor, okay, and this positive and negative will go to one more motor, okay, and here you all have this 4 pins, right? IN1, IN2, okay, IN3, and IN4. Four connections. The first IN1 and IN2 will go for motor 1, IN3 and IN4 will go for motor. At this situation, right now, I don't have an external battery source. I mean, this particular single stand wires to connect to a battery. That is only the reason I cannot show you this L293D. I have my DC motor ready to work with, and I also have my chases to show to you all. Again, this is a chases that we generally work for on the beginner level students. And of course, we do also have some rover kind of things to, if at all you want to try, okay? All right. So something that you're able to see this black one, it's MOSFET. And I don't think that subject knowledge is useful to you all at this point. Okay. So this is the diagram and this is how really you work to connect to it. Any questions here you can ask. Any questions like how to connect everything. And of course, do not worry, we are going to do this particular L293D again in our next hardware session. The same thing with a little advanced where you can connect not only two motors, but more than 50 to 60 motors can be, sorry, 5 to 6 motors can be operated straight away is with this motor. This is called as motor shield. Okay. Because you have an L293D motor separately operating for a DC motor, but this motor shield, you can connect your servos, you can connect your DCs, you can operate stepper motor, anything. Okay, you see here, if at all, I don't think you guys can see all the names ICs that are written on the black ICs, but if possible for you, I can read out. All are made from Texas Instruments, and one is from ST Microelectronics. One is LT9TV and no, not LT9TV. The names are a little different, but the operation is that you can connect any kind of motor to this and you can start your what you call programming. But remember one thing, when you are using such a big motor shield, you need to have supported drivers, and supported library files imported, because this pin diagram, okay, this pin structure, whatever you are able to see here, this pin structure is different when compared to these pin structures that you are giving to your Arduino, right? So what I'm trying to tell you is this alone can be used to directly dump the program and utilize for work. Got it? That's a little advanced, not worry. And yeah, when it comes to actuator systems, so I do have only a micro servo at this moment, but let me check if possible. I don't think I can have. Yeah, not a problem. I don't have your sensor. I mean, like any other sensors at this time. Yeah, you see here, this only this motor is right now shown to you, but of course we can also have stepper and DC motor shown maybe in the next whenever we are working with Raspberry Pi. So see this. So this is a micro servo, and people give a lot of names like this. Thrust will be 1 kgs, 2 kgs, 3 kgs. Don't believe anything unless and until you test it. So how do you test a servo motor, and how do you test its particular thrust? Because a lot of people who work with servo motors in robotic arms and a lot of other stuff, this particular thrust is very much important. Okay. Okay. Once again. Let me connect it to, yeah. Let me try to connect this, and I need again one signal wire. So I'll do only one signal wire now. And how many of you observe that this particular motor driver, when I show you, it doesn't have what do you call this? Let me tell you, enable pin. This motor driver, whatever I have shown you, it doesn't have any enable pin. It just used to turn on. I mean, like right and I mean like clockwise and anti-clockwise. That's it. You don't have enable option over here. This is a very old one. This is a very old one. I'm showing you a little bigger one as well, but I don't think the stuff is with me. Anyways, yeah. Okay, let's first finish off this because measuring the thrust. Okay, sorry. I'm speaking with respect to quad rotor. We can call this as torque. Okay, when it comes to this particular uh, servo motor, we call it as torque, not thrust, torque. Okay, again, I'm taking this particular signal wire, the last one. This one, the lighter color is called signal, and the red color always stands for VCC, and the next to it, which is a little dark one, is for ground. The first thing, I'm connecting the signal wire to one of the digital pins on our Arduino. Okay, let's connect it to some pin. Okay, let's fix it to 8. Okay, 8. And now I need to also connect your other things. Let me check the GPIO. Standards. Yeah. So this. Let me remove two from them. Yeah. So 5 volts and ground, utilizing the same 5 volts and ground. So this ground goes to this ground. Yeah. Anyways, I think the connections are strong enough. Let me see. 5 volts and volts. Yeah, ground. Okay, let's plug in our, or whenever I think whenever it receives power, it tries to rotate in some fashion. Yeah, it's rotated. Anyways, that's not a problem. Let's open our, one second. One second. Just give me 1 minute. Let me open your servo motor program that we try to use. Three. Three is our program, right? Sorry, sorry. Okay, open it because previously for some other class I just changed the program. Yeah. So I think I gave it pin number 8. So let me give it 8. So I think we explained this program in our previous class. I think it's not now mandatory to explain this again. Everyone able to see the program? Did I share the screen? Oh, not yet. Sorry. Sorry. Yeah. So once I uploaded it, now I'm just pinning off the video. I'm just clearing out this particular screen share because you can see it when it pins. You see now, it's now able to rotate to 180 degrees, go back to 0, go back to 180, go back to 0. It's going on. And it's not because it's in a loop. The loop, whatever you wrote, it's not coming out of loop. What was my previous consideration to you all is, now let me tell you, I'm just unplugging my Arduino. Okay, I'm just unplugging my Arduino. Okay. So now what do you think? Now the program is stored in its memory and it is now executed without uploading because the previous program is what always executed. You're not doing anything now. So it starts rotating again. So the previous program will always stay in the memory. So now let us test the reset button also. I pressed reset. So again, it's the same program runs. Reset is what doing? Reset is what pausing everything and again execution from the beginning, right? The same thing is happening over here. Okay. Okay. Now for your understanding, you were asking some questions yesterday. So let us try to use them. Let us try to see them. So yeah, this was your program's questions, right? So what was your question like if this delay is greater? Okay, for your understanding, let me take this to 1,000, okay? And let me also take this to 1,000 for symmetry. Let us upload this and see. You see how slowly it is rotating. At least you are able to see that it's rotating. Anyone? So it's even. I'll point it too high at least. So this is what I said. If you increase the delay below, the loop will take much more time to execute. Let us cut it down to 100 and see if 1 second is much more. Let us cut it down to what you call 100 microseconds, so 100 milliseconds and see. So now see how slowly it is doing. This was the question that was asked yesterday for you for a car wiper with three different positions of three different modes of operating: fast, slow, and very slow. So what I need to do is, so it is going to one corner. I mean, like it is going to this corner. Maybe it will come to this corner now. Okay, right? It touches my finger and then it goes back again. Right? What exactly in car wiper happens when it comes to when it goes down to your steering point? It will wait there for a moment and then raises. To implement that, what we need to do? Anyone can answer me this question? To implement a similar kind of analogy, what we need to do? We need to add simple one line code. What is that? So here it's not stopping on the two extreme corners, it's coming back immediately to this corner. But to implement the similar kind of stopping at one point and again going to another point, to pause here for, to pause at this extreme for a second and to pause at this extreme for a second, what I need to do exactly? Anyone? Yeah, it's only one line of code, one line of code that I need to add. Come on, why are you guys too scared? No, very simple. See, when it goes to this particular corner, okay, I just need to add in the end of this particular what do you call for loop a delay of maybe 5,000. It means I want to have a 5 seconds delay. Okay, if it is too long for us to observe, let's make it 3,000 delay. And 1 second. After this, what do you call loop, I also want it to wait for 3 seconds. It means when it touches two extremes, it will wait for 3 seconds to again initialize. That's it. Obviously. Let's try this. And yeah, before doing it, let us also make it to 50 now. Okay, let's try to make it 50 so that it may be a little fast. We can observe those delays that we are trying to implement. So it's not going. When it implements the first for loop, whenever it touches 180 degrees, it has to stop for 3 seconds. There. 1, 2, 3, back. One, two, three, again back. That's it. Very simple, right? So to implement the car wiper, we need to reduce the delay time that we are taking for each corners, and then we need to give the similar kind of analogy for it. Very simple. This is what your car wiper is doing, right? Clear, everyone? Understood? So I don't think this will be that tough for you to implement a small car wiper kind of project for your own car if you want to make. What say, guys? So I think this could be the end of today's session. We worked with three sensors and one servo, right? So maybe by the next time, whenever we work on Raspberry Pi, because Raspberry Pi 90% could be something like a pocket computer, I will show you how do you connect your keyboard, how do you connect your USB mouse, your display through HDMI, how the Linux command works, and how exactly you install the software, and what is the remote working protocol that is required if at all you want to work it from your particular system. Everything will be displayed and the stuff goes very well. Okay, but when it comes to this Arduino, you make your hands as much dirty as possible with a small developer board which is not more than 400 or 500, and at least I'm not worried about the amount. If you want to have this particularly implemented without any stuff in your hands, go to that simulation software, whatever I said, try to implement the same thing. Got it? Clear, everyone? Enjoyed today's class? Maybe actually, I don't have access to DC motor at this moment. See, I can show you the DC motor with a plug and play model, but that will not be that useful because the logic, whatever you are trying to implement, okay? One second, let me try to, yeah, just give me 1 minute, hold on. See here, this is a plug-and play model of your DC motor, okay? What I'm trying to do here, just hold on a minute. So see, the same thing whenever I switch it on, the motor runs. This is just a switch on and off model, but no direction control, no speed control. To do both of it, we need a DC motor with a dedicated, what do you call, a 9 volt supply and all. So there are little things missing because you guys know the situation outside, and maybe I don't tell that as an excuse, but it will be shown by the next class. Okay. Sir, can you please tell why we use servo.attach in the code? Yeah, why? Because we have included servo.h library, right? So to tell where my servo is attached, it means connected on your Arduino, you need to tell where your pin is being connected. Hence, we use servo.attach as a function to tell your particular Arduino where your servo is connected. Yeah, Vamshi Kishore, is your doubt clear? Okay, you are not able to log in Tinkercad. You try the same thing what I did now, as of now. Sir, there are interference between waves generated from trigger. I don't think so. I don't think so, but possibly in sound, what happens? This is a very smaller one. The resonators are very smaller values, and if you take a bigger resonator, it will be disturbed when you have what do you call? You are speaking. I'm speaking from sideways, right? Even that also disturbs it. Always remember these resonators, whatever are present, and this photodiode, whatever is present, they all only work with particular wavelength only. Okay, they don't. I don't mean like they don't work for any other. They are designed to work at some frequency and some wavelengths. If you put analog right and use half duty center, you will dim the resolution. Obviously, obviously, yeah. Will definitely, it will definitely do it. Once again, once again, I have to go to your last message. Sir, can you please give the connection between the motor, driver, IC, and so I can try talking to that. You try it. You try it. Send me a screenshot. Why are you worried about it? You just try it. You just try. What exactly are required? You all know. IN1, IN2, and VCC, and ground to external motor. Enable pin to one of the pulse width modulation pin. IN1 and IN2 for digital pins. Okay, you want to try it in Tinkercad, okay? For motor driver of IC, you want the corrections, right? I'll share you an image in WhatsApp groups, okay? Follow it, okay? Follow it for corrections. That will be very useful. Because even if I orally or manually tell it, you don't take down any notes and you'll definitely forget when you start your test. So for that, I'll send you an image. You can use that image straight away. Got it? Yeah, I think most of you enjoyed this class because it was 90% hardware and 10% theory and other stuff, right? There are more to come because in advanced courses, I literally show you a robotic arm which is picking and placing, and of course, it needs a lot of mathematics and all required. And if you all guys have really liked this, I think you like it. Because no other company does this kind of what you call tutoring and this kind of online sessions parallelly along with their pre-recorded sessions or anything. Anyways, our ultimate aim is to make you all guys understand the stuff and do at least one domestic product for your home. Hope you all understood the Viper point and at least you try it. Okay, at least you try it. And any difficulty, let me know. Let's try to solve it. Yeah, any more questions? Shall we leave? Meet again coming week for your regular class. And before coming to regular class, one more reminder to you all, evening 7 p.m. to 9 p.m. you all have Python class for people who got registered for Microsoft. Okay, great. And this session is also recorded for only one person who asked me to share it, because I don't want him to miss any kind of hardware. I just, sir, I have a little problem with Chetu. Could you please text in the WhatsApp message, because today I'll be handling your WhatsApp group, so you are going to speak with me directly. Okay, you can text me there. I'll speak. Yeah. Okay. All right. Have a nice day. See you all in coming class. Bye bye.